So in this video, we're going to look at the Avogadro constant and molar mass. So Avogadro, who's a scientist, had the idea that equal volumes of gas at the same temperature and same pressure contain the same number of molecules. And this is kind of an odd thought on the face of it, because when saying nothing about, what the mass of those gases are or the size of those gas molecules, maybe we're thinking about, say, hydrogen the hydrogen molecule is a lot smaller than a nitrogen molecule, both in terms of size and in terms of mass. But what we're saying is that we'll have the same number of hydrogen molecules, at least according to Avagadro, in this volume V here, as in this same volume V of nitrogen molecules, which are N2. So we're going to see that it basically kind of is the case, more or less. It's an idealization. It's not like a scientific fundamental truth that this is the case, but it's a very, very good approximation for almost all intents and purposes that we'll kind of come across. So it's an idealization, which basically states that the volume of the individual gas molecules don't affect the volume of the gas. It also ignores the different attractive forces they might have. Why does it do that? Well, what it basically says is that if V is the volume of our gas, it basically says that's much, 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 much greater than that's not quite the way of putting it. If I say that basically it's like saying that the spacing between our molecules, this is a better way of putting it, the spacing between our molecules is much, much, much greater than the volume of our molecules. So that clearly means that the volume is much bigger than the volume of our molecules, but that's not quite true, because we could have them tightly packed together. And then the molecule size would matter. But what we're basically just saying is that because the spacing is so much bigger than the molecules, that is to say that the distances between each nitrogen atom or each hydrogen atom are so much bigger than the size of each of those molecules, that the volume that these molecules take up has no impact on what the volume of your gas is. So the volume taken up by the molecules has no impact on the volume of our gas. They're insignificant, which basically just means that the volume of the gas is just the volume of the molecules. We can just basically treat them as point particles. So we treat them as point particles, that is to say that they don't really have any volume, because we don't, in this level of approximation, they just have no impact. They're so small compared to the spacing between them. The other thing we do, that I've just said there, is that we, and sorry, just to be clear, this would be an H2 and this would be an N2. They're diatomic molecules, which means that they're two atoms joined together. And the other thing we do is that we ignore the different attractive forces that they might have. So what we might find is that a hydrogen atom attracts another hydrogen atom, which attracts another hydrogen atom. There's some forces perhaps that cause them to be attracted towards each other. But again, what we do is just say that those forces are so weak.
Hey guys. To continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.